Well, welcome everybody. Today we're going to do part 2 of EagleCAD libraries, which is EagleCAD libraries. The basic series is about using EagleCAD, and so we'll just jump right into the first screen here. And so I'm the presenter. My name is Jonathan Fant. I'm a licensed professional electrical engineer. Daytime job, electrical engineering manager at EAD Engineering. I do not do what we're looking at for a living. I design large power systems, typically for industrial clients. But I have a hobby business on the side, and it's called Scaled Automation, and that is where I do what we're talking about today. So I design circuit boards and typically have embedded processors on them and write the control software for them. My focus right now is model railroad controllers, and that I design controller boards. I write embedded software for the controller boards, and I write personal computer software to drive it all. And you can see my contact data there. Anyone has any questions, feel free to call me, or even better, send me an email. So our objectives for today is we're going to review a little bit about Autodesk Eagle. The best review is to look at the part number 1, where we covered a lot of this, so we'll go through it pretty quickly just as a reminder. And so we're going to look at schematic entry, board layout, and then how to do a design rule check. We will then focus on the main portion today, and that is Autodesk Eagle libraries. And of course, those are, you start out with them coming from Eagle. They have a number of libraries already included, but there are also a lot of third-party libraries. You can make a custom library and you can build your own parts. So we're going to talk about all of that today. One of the things we're not going to do is we're not going to go into everything there is about libraries. This is enough to be very functional, but there is more that can be done. We're going to leave off the stuff that doesn't get done very often. So for today, first thing is we're going to review a little bit about Eagle. So why Autodesk Eagle? There are a number of printed circuit board design softwares out there. But Eagle's been in use for some time. It's been pretty fine-tuned. It has very good capabilities, and it's relatively low cost. Again, refer back to part 1, more details on the low cost. Particularly for hobbyists and startup companies, it is extremely low cost. There's a lot of support by manufacturers, so Eagle libraries are easy to find, and almost everybody has them. It's really easy to order boards from Osh Park, which is a company that makes printed circuit boards. You actually send them the Eagle file. You don't have to break it apart into the 13 or 14, whatever number it is, of files that are typically used. Just saves a huge step, makes it a lot easier. The other thing is it's integrated with Fusion 360, which is a 3D design environment. And so you can integrate electrical and mechanical design. And nowadays, in the new subscription methodology for Eagle, you actually get Eagle and Fusion 360. And again, we're not going to go into 3D today. We're going to focus on libraries. So printed circuit board design overview. You're going to gather data sheets of components. We'll see that a little bit later today. Hand draw a schematic if you need to. If you're pretty familiar with schematics, you may not have to. You may have a reference schematic you're starting from. Then in Eagle, we're going to draw the schematic, and that's sometimes called schematic capture. We're going to put that schematic into Eagle. During that phase is where we're going to start interfacing with libraries, and you'll see that when we work through this. Once the schematic is done, or at least mostly done, we can start laying out the board. Once the board has all the parts placed in the correct locations, then we can route traces, and Eagle has an auto router. I find it difficult to use, and it usually doesn't route the kind of stuff I'm doing because I'm trying to make the boards as small as possible. I will almost always route all my traces by hand. And then last step, once you got everything done, you think you're all done, you're not, because you're going to run a design rules check. And design rules looks for things like proper spaces and hole sizes, distances from boards, component distances from each other. Make sure that all of your traces have been routed properly. We'll look at that a bit as we go. And then you order your board. Once the board comes back, you'll assemble it and verify operation. So that's kind of the overview of the whole process. And again, at the schematic stage, we'll start interfacing with the library, and that's what we're going to focus on today. Schematics, you add devices from libraries. That's what I just said. So you can use a search feature, you can find devices on the internet if you don't have them, and then you can create them from scratch. And once you put the device into the schematic, you're going to add wires, they call them nets, to connect things. And real quickly, I'll zoom into this picture and kind of show you some of that. Come on, zoom in. There we go. Okay, and so on this, you can see that the devices have these little green wires hanging out from them. Those are what they call nets. Because they're not technically wires, they'll end up being traces on the board later. And you give them names. And what's really cool about this program is that I don't have to draw from one to the other. I just give it the name and it knows to internally connect it. So it makes your drawing a whole lot cleaner and easier to see. So if I had to connect all those wires, you'd have a spaghetti mess and you wouldn't be able to see it. So that's what's really cool about using named nets, is that it saves a whole step there. Okay, so we're going to name the wires for the signal that's on the wire, make it something that's easy that you can kind of make sense about what it is. And then all the names that are common will connect automatically, as I said. Then you can add text and a title block if desired to your schematic. If you were releasing it out to the public, you'd almost for sure want to do that. If you're just making a board, you don't have to add much to it. Board layout. So initially, the devices are going to be off the board, and we'll see a little bit of that in a minute. So, and you're going to start placing them on the board. And I'm going to do another zoom in real quick, and I can push the right mouse button. And at this point, I've put the components onto the board in the right places, but you can see these little yellow lines. Hopefully that's visible on your screen. And you can see that those little yellow lines are not traces yet, and you can see that they cross over. When you're placing components, you can look at those little yellow lines and figure out where to place components if there are options, and minimize the amount of crossover of traces. That'll make it a whole lot easier later when you turn those into traces. So once the components are placed, then those are called air wires, by the way. That's the term they use. They're not wires, and they're not in the air, but they're called air wires. But they're used to show you the signals. That shows you where every component connects. And so we're going to turn those air wires into traces. And again, the auto tracer can do that, or you do it manually. And we'll show a few examples of that today. So in positioning devices, place the devices that you have a known location for first, and then place other devices to minimize signal links and avoid that crossing over I talked about. You'll add mounting holes. You'll add any text like the name, like I put scaled automation on there and I put a rev number on it. And then you'll route the traces. That's our basic steps. So in routing traces, I always do the power traces first because those are going to be larger traces, and we don't want them crossing over. Signal traces, we can route around things a bit. And then ground is actually what's called a filled plane. And so we'll do that last. That can be a tricky step, but if you Google search it, it'll show you all the steps. It's not that hard. It's just not an automatic step. You actually place a rectangle on the board and call it ground, G and D, and then push one more button and it will automatically fill it. So what I do to make these traces work when I'm routing them, I use one direction for the top layer and the other direction at 90 degrees for the bottom layer. It just works out that way on each top or bottom layer, you don't have traces trying to cross each other. Because of course they can't cross, because if they cross, they would touch, and that's not going to work. So typically I'll use horizontal traces for the bottom layer, and I'll use vertical traces for the top layer. As I mentioned earlier, complex designs must be hand routed typically. You can use the auto router if it's simple design. I'm going to spend some more time looking at that, see if I can figure out why I can't make it work right. See if I can give some guidance on that in a future session. And then when you get to the end, and I said last traces, what I mean is when we're done and we got almost all the air wires traced out, sometimes you find things just didn't work out the way you started. You're going to have to rip them up, which means convert them back to air wires and start rerouting. So particularly on very complex boards you can almost always end up having to rip up some. I'll show you a fairly complex board today. And then add ground planes using polygons for the outline and name as grid. I mentioned that earlier. And the button you're going to push is called Rat's Nest, and it'll automatically fill it in. So some of this stuff is historic. I have no idea where the name came from for Rat's Nest. And then last, once we get anchor done, again, we're going to use a design rule check. And you must set the design rules you're going to use. OSPark has their own, so that's cool. You can get it from their website, and they'll run a design rule check when they receive your order. So if you do it first, it means theirs is going to go right through. You're going to click Tools, and then up will come the dialog box that you see here. And I'll zoom in again. If I can make it work, and zoom in. There we go. And magnify it up a little bit here. And basically, you're going to load the one you want to use. And in this case, I've already loaded Eagle design rules here. But if you're using OSPark, it would say OSPark. And we'll do an example of that today. And then hit check at the bottom. So check is where it actually starts the design rule check. So that's where that comes from. And it will do its thing. It'll automatically work, and it'll tell you if you have errors, and we'll probably see an example of that as well. And you eliminate those errors one by one until it runs with no errors, and then it's good to order. Then you order the board, and again, I like OSPark. There are others. It's not the only one. OSPark is really easy to use. They're pretty inexpensive. You get 3 boards at a time, and so you can't order 1 board or 2 boards. You have to order 3 boards. And that 3-board order is for a double-sided standard weight board is $5 per square inch for 3 boards, not per board, but $5 per square inch for double-sided boards, and you get 3 of them. Usually takes about 2 weeks. You can get it faster for higher cost, and you can order more than 3. It's just 3 is the minimum. I like OSPark. They're a good company, and they're always very responsive. So the example project we looked at last time was this making a portable case for the Digilent Analog Discovery 2. And that's a pretty cool little device because it's not real expensive, but it's a 2-channel, 30 megahertz oscilloscope, and it has a waveform generator, has 16 channels of logic analyzer, plugs in through USB to your computer, run their software, the USB connection powers it. But it's not, I'm not sure what to say, but it's a little case. It's not real. It doesn't look like an instrument. And when you order the part to connect the oscilloscope leads to it, it's a bare printed circuit board. So it's not real. I just think it doesn't look like it would be a real good thing for a working workstation. And so I thought I'd build a case for it. I put it in a case and give it some hard connectors. Well, the problem with that is that why this became our example project is that, come on, I'll zoom in again. Right here at the bottom, I needed a front panel board. I need a board to hold the BNC connectors and the switches, and then that would mount to the front panel, and then the board itself would connect back to the Analog Discovery 2 module. And so I just needed something to hold the connectors basically to the front panel. So we designed a printed circuit board for that. And we'll look at that in a little more detail here. So here's the custom printed circuit board that was made. And this is with the BNC connectors mounted on it, soldered in. The switches, the slide switches that select different characteristics like AC or DC for the oscilloscope traces, and then the impedance output of the waveform generator. You notice on the right side there's dual row pin connectors. That's where you plug in the logic analyzer. To the left of that is where I soldered all the wires that actually go out to the Analog Discovery 2 module. So it's not a very complicated board, but it's on the other hand, it's very useful. So this custom board was designed in Eagle. I had to make one new device, and that actually was the BNC connector. The one I found in the library didn't match the spacing on it. And it wasn't hard. It was an easy one to design. And then the steps are kind of interesting because I used Eagle Export, an export out of Eagle, which will actually export a number of things, but one of them it actually exports is an outline of the board and all its components. And it's very precise and exact, and it went into AutoCAD. So AutoCAD is extremely precise. And then I used that file that was in AutoCAD to make the front panel openings. So the devices themselves are not the openings, but I used AutoCAD to put openings where those devices were. So holes for the BNC connectors, kind of rectangular openings for the switches, another rectangular opening with a little cutout for the logic analyzer connector, and a few others that you'll see. And so I did all that in AutoCAD, and then took that AutoCAD DXF and put it into Front Panel Designer to actually make the front panel. And another step was I used a program called Inkscape to make the graphics, and Inkscape is a free no cost program that looks pretty capable, so I really enjoyed using that. Put that all together, used Front Panel Designer to make the front panel, and then ordered the front panel from Front Panel Express. So Eagle, as you can see, was kind of the start of this, the board itself, and then designed the front panel around it. And the final result was this device. And we'll zoom in again. The zoom in wants me to click twice for some reason. So this is what it came out looking like. And again, the board is behind there holding the BNC connectors and the switches, and you can. I think it came out really nice. It looks like a nice professional instrument that you can use on your desktop or on your workstation. So the finished project looks professional. The custom printed circuit board fit perfectly. That's the amazing part, is the layout started in Eagle, went through AutoCAD to make the openings. So everything was done digitally, didn't have to redraw it. It's a very useful instrument. 2-channel, 30 megahertz oscilloscope, 12-bit, by the way, not 8-bit like some of the cheaper ones. 2-channel waveform generator, and you have a variety of waveforms that will generate automatically through your control in the software. 16-channel logic analyzer, positive and negative controllable voltage sources, powered by the USB connection to the PC. And it's just been my experience, it's almost impossible to get everything perfect the first time. So I have to make a couple minor modifications in order to begin production. I'm planning to offer this for sale as a kit or finished, and for folks that would like to have this type of instrument on their desktop as well. So I'm really pleased with the way it came out. But let's just jump into what we're here for today, and this is libraries. So libraries in Eagle CAD are a powerful thing because they're very flexible, and you get to control a whole lot of it. And manufacturers offer these libraries. They comes with a bunch of libraries, and what's even more cool is you can make your own. And there are so many libraries, and there's so many parts that get spread out all over the place. But you're likely to use only a few, a handful, several dozen, whatever, how extensive you're going, and you can put those in your own library. So that's kind of the overview. So we're going to talk about it a bit. So the important thing to remember is libraries hold devices, and the device is used in this context to mean, I'm going to zoom in here again. It makes me want to do it twice every time. And so you can see up here in the upper right corner of this screenshot here, there's a symbol on the left. There's what's called a footprint on the upper right, and then there's a 3D model on the lower right. Those are the three basic parts of it. The part we're really going to need is the schematic symbol, and we're going to need the footprint. The 3D part, the 3D package, very useful if you're building these things in 3D and you want to know clearances when you put it into the package or whatever. But for just making the printed circuit board, you don't have to have the 3D part, but you do have to have a symbol for the schematic and a footprint. The footprint, of course, is what will become, when the printed circuit board is made, it will become the traces to which you'll solder that particular device onto the board. So very important. So So many libraries are included with Eagle. It comes with a lot of stuff. And when you first start, it's going to be very challenging to find anything. I'll show you, let me go ahead and do it right now because we were there. And down at the bottom, there's a search field that you can put in and attributes. And so you can put in a search for a part, and if it's within the set of libraries that you have, it will come back with that. And it'll show you which option. Sometimes you put in a search and it'll come back with a dozen or so, and you can choose which one you want. So search can be powerful. It can also be frustrating because things you know are in there for some reason doesn't always find them. So use search if you can to find your parts in the libraries. So likely, sooner or later, you're going to need some devices that are not included because there are so many thousands of devices out there in electronics nowadays that you're not going to necessarily have it in your library. So AutoDesk actually has additional libraries, and those libraries are not hard to find. And we're going to do a Google search real quick, and we can take a quick look at that. Let me get that pulled up and moved over. And what I'm going to type in now is into Google, I'm going to type Eagle Libraries. And when this comes up, the first thing right at the top is going to be, or second from the top, is AutoDesk Eagle Libraries. So we're going to look at that real quick. And here, again, they have so many that you're going to have to use a search most likely. But if you're after a specific part, if you put that in here, it will search. And again, there's just many, many, many of these. And once you found the one you want, you'll hit the download, it'll download, you'll put it into the library directory. We'll talk about that in a little bit. And there you go. So easy to find new libraries on the net. But notice also that in this Google search, there are a whole bunch of other ones. And one of the ones I like a lot is SparkFun. SparkFun's a company that makes a lot of hobbyist stuff, and they just happen to have a lot of footprints in theirs. You can get theirs off of GitHub. So I've downloaded it. I like it a lot. So, and then the last option, if Autodesk doesn't have it, if it wasn't included with Eagle, Autodesk doesn't have it, Google search didn't come up with it, you're going to have to make it from scratch. And so we're going to spend some time looking at that today as well. And the last point is, and I mentioned it earlier, you might get to the point where you've got so many devices and it's so hard to find them that you're going to want to create your own library. And I did that. And so it collects devices that are commonly used into one place. So it makes it easy to go find your devices. It holds devices you create, because if you make one, you don't want to put it in somebody else's library. If it gets updated, it gets overwritten, and so you might lose your device. So put it in your own library. And then the other thing, it's really cool, and we'll also look at this today, is that it can hold devices you modify. So the library that something came from might not have something you want, might be too complicated. There's a number of reasons why you might want to modify a device. So you put those in your own library, give it a unique name if you like, and then you can use that device that you modified. And we'll show some examples of that today too. So library components, we talked about this already. Make sure we understand this. Libraries hold devices. So a device can be almost anything, an integrated circuit, a resistor, a capacitor, an inductor, a connector, a jack, a battery. I mean, it's just the amount of things that it can hold are almost endless. But in the end, what we're going to do is it's going to be something that's going to get mounted on a printed circuit board and have traces connected to it for electricity. Having said that, it's an exception to that. It's an important one, and that is things like mounting holes are also devices. They may not have traces to them, but they certainly have a footprint. They have a hole size, and they might have a piece of copper for isolation or a piece of copper connected to ground. So even a mounting hole is actually a device. And the symbol that's used in a schematic for mounting hole, sometimes this is an exception. We won't necessarily have a symbol for mounting hole. You put it in when you make the board, you don't put it in the schematic, but most times you're going to have a symbol used in the schematic, a footprint that corresponds to that in the board, and potentially a 3D package. Some you make yourself, you may not have a 3D package, you may not go to that step. But really highlight the symbol and the footprint are needed to produce a printed circuit board in almost all cases. So library searches, and I got this out of order, we've already done it, but I included here the address for the website address for URL for the Eagle AutoDesk and their libraries. One thing I didn't mention a whole lot was manufacturers' websites often have these Eagle libraries as well. So, or Eagle device definitions for you to put in your library. I mentioned that SparkFun is a good resource. And then vendors, this is another one that's interesting. If you go to, I use Mouser and DigiKey a lot for my sourcing of my parts, and Mouser in particular has a subscription service for free to the users. When you are browsing for parts and you go to their parts page, they have a place for you to download CAD libraries, and it includes Eagle. So, so you can add that to your library and pick up parts that way as well. So the steps: locate the library, download the library, we talked about that. And where you're going to save it is the Eagle/libraries folder. And where that Eagle folder is can vary by system, but typically it's under your documents page in Windows. So in your user space. So you'll need to find that and know where your libraries are stored. And then you can use that library as is, or you can copy the devices into your own custom library. So that makes it very handy. Again, a custom library to collect things. So let's talk about making a custom file, a custom library file. So I'm going to describe the steps and then I'm going to show them to you. So we're going to open Eagle. We're going to click File, New Library, and click File, Save As. Type the name for the library. Then we're going to import or create devices. So let's do that real quick. So the first thing we're going to do is I'm going to start up Eagle. Okay, so here comes Eagle. And it's pretty simple because remember we're going to click File. It's in the upper left-hand corner. Click that, and then right underneath it is New. And we'll click that. It will actually drag over to Library. File, New, Library. When we click that, we're going to get the library editor come up, and of course it's on my other screen, so I'll move it over. And you get a blank library. And of course it says it's untitled. At the top there's the location. In my case it's C/users/C/documents/Eagle/libraries and untitled.lbr. So good practice. Don't have to do it in this order, but good practice. Let's go ahead and name it. Let's do a file, save as, and I'm going to call it, just because this is a new one, we're just going to call it New Library. You can be a whole lot more creative than that. So the library that I save everything for scaled automation is called scaleautomation1.lbr. So save them however you like. If you want to have several libraries, you might save them as different types. So New Library, and we're going to hit Save. Okay, so now it has a name, but it still doesn't have anything in it. So I'd like to add some things into my library, and I'd like to pull them off of an existing library. And so I'm going to add device, and right at the bottom in the left-hand side is the tab for Add Device. And before I go into that, real quick, notice that we have 4 basic areas plus a 5th on the very right side. The first one on the left is called Device. So that'll hold our devices. Next to it is Footprint and 3D Package, and then going over one more is Symbol. So we're going to collect all of our footprints, 3D packages, and symbols together here, as well as our devices. And remember, we said a device is made up of 3 things: a footprint, a 3D package, and a symbol. Now, I think they're out of order. I would have put symbol first, but that's okay. It's just the order. And at the bottom, in each one of these panels, notice there's an add. So add device, we can add a footprint, we can import a 3D package, and we can add a symbol. So we're just going to add devices right now. We're going to add, and the nice thing about adding a device, it brings all three of those components in at the same time. So I'm going to click that, and it says new. If I want to make a new one, then it's going to say new device name, and I'll name it. But there's a button right at the bottom called import, and so let's import a couple. I'll click that and wait for a second. And now here, almost all of these are the ones that came with Eagle. So I want to show you that this is, the amount of stuff you get is just incredible. It's just a huge amount of libraries that come with this, come with Eagle. And again, because there are so many, if there are things you use all the time, let's collect them in a custom library and just makes them much easier. So here's a couple, here's one right at the bottom I want to use. And if you look really close, you can see there's a sideways triangle pointing to the right. That means there are sub devices under there. That's not the one I want. I want to open it, so I'm going to click it. And here's the piece I want right here at the bottom. So when I click it, notice that it shows me the symbol and it shows me the footprint over on the side, and then there's some description of it. So this is a micro USB Type B connector. And those are pretty cool, and I didn't have to do anything special to make it. I found this actually from AutoDesk's their Eagle library page that we were looking at a while ago. And I thought, well, that's pretty cool. I won't have to lay that out myself. I can just order it, and they've done all the artwork and everything. And so I downloaded it, and there it is. Well, I want to put it in my library. So now as I've clicked on it, I can hit OK. And it takes just a minute. And then it comes up into the actual device editor. But at this point, I don't want to edit it. It's already good to go. I'll expand the top little row a little bit, and you can see it. Again, it's showing the symbol on the left side. It's kind of in the middle is the footprint. And it's already connected and ready to go, so I don't need to do anything. So that one is the device editor, but at the top, hopefully you can see where my cursor's at right now. There's a book. It looks like a book with the pages open. And as I hover over it, it drops down. It says Table of Contents. So what I really want to go back is this Table of Contents. That's what this is. I think of it also as the library editor, but it's a Table of Contents. And notice now we have our device that we added. So that's pretty cool. That's all. I'm starting a new library, collecting my devices, and here's the first one I've added. So let's add a couple more just for fun. So we're going to import again. And one that's very useful is one called pin connector or pin head. And so we're going to go down to pin head. Kind of a funny name somebody came up with. Here's pin head right here. I'll expand it. Notice I got lots of them, tons and tons of them. So I want to do a 1x2. And notice here they have two variants here. So one is a straight, and oh, look at this one. This one has a 3D image of it also, so really easy to say what it's going to look like. And notice this is a 1/10 of an inch standard header with two pins on it. They also have one below it that's a 90, and so the one that's straight and the one's 90, but I want the one that's straight. I'll pick that one. And let's say I also want a 4, so I'm going to pick that one. And see if I can do two at once. So I'm going to pick a 1x2 and a 1x4, and we'll open those up. It'll take a little bit, and look, I got two of them. I ended up with the 1x2 and the 1x4. So that quickly, now I'm starting to build my library. So that's how we're going to add from other libraries into our library. So I'm going to minimize this real quick, and we'll get back to our slideshow. So again, make a custom library. You're going to click File, New, and Library. You're going to save as, give it a name, and then you import or create your devices. So what we just did was the import step. And in a few more slides, we'll talk about creating new ones. So import devices, open a library. This is what we looked at earlier. I showed you on screen, a little bit bigger view of it. Click Add Device, click Import for importing. Select the import devices. And with, I call it the device select dialog box. Choose the device to import. Use the search feature. Remember that search feature is there. You can look for devices. Multiple devices can be imported at once. I showed you that, but only from one library at a time. So you can't select multiples across different libraries just within a library. Be nice maybe if they could, but on the other hand, it's only a few steps. hit OK when you're done. We did that. So let's talk about modifying a device. So I might have something in my library that I want to modify, and I'm going to show you some examples on it. And I can modify either the footprint or the symbol depending on what I need to do. I'll make those changes, and then I'll click File, Save, kind of standard steps you would expect. I'm going to show you an example of something that I'd like to change. So we're going to go back to Eagle real quick. And I'm going to open up a particular, I'm going to go ahead and open up a particular device I'm working on. And this is for a model train speedometer, basically, or a speed trap, so that you can determine the scale miles per hour of a train. And this particular device is not very complicated. It's got a microprocessor on it. It's got a USB interface chip. It's got a clock oscillator. It's got a power regulator. It's got a USB port on it. And the part I want to modify is my capacitors don't have a symbol that I want. So I'm going to, the next thing in Eagle is that, so this is the schematic. Under Window, I can choose to go to the board. So I'm going to open the board up. This is what the board looks like. And remember, I told you some of mine get pretty complicated because they're so small. And this little board's only a couple inches long and a little over an inch wide. It's got a lot of parts on it. And so, but one thing that happens on this one, and I'm going to zoom on in right now, these resistors don't have an outline around them. So if I go to the manufacturing tab on the right side and I click that, this is kind of a cool feature for Eagle because it shows you what that board will eventually look like. And notice that, and I'll zoom in some more here. Notice that my resistors, the pads are there, but there's no outline for it. It'd be kind of nice to have an outline on it. You'll see in a minute when I put those outlines. It just makes it easier to see where those components are. And if you notice all the way on the right side, C1 and C2, they don't have hardly anything around them. It's just a couple of pads. So when we go to build this thing, it'd be a whole lot easier if I had some outline for those pads. So we're going to do that. So the first thing we need to do is we need to get into a library, and we need to edit it. So here's, I'll show you a real cute little thing that's very nice. I want to see this resistor. I want to see exactly what it is. So I right click, sorry, on the mouse, and I hit Properties, and it tells me that it's under footprint, it's R0805W. So it's a resistor in the 0805 size, and they added the W because it's made for wave soldering. I don't really care about that right now, but it's the one I'm using. So we're going to go and find that real quick. The top, on the very top, there's a tab for library. So we're going to do library, open library. And I happen to know that this one came out of my scaled automation library. So I'm going to open that up. And it just asking me to save. And that's my new library. So I'll say yes to that. So here's my my scale automation one, and I need to find my resistor. So I'm going to scroll on down. And my resistor right here, resistor-SMD-0805. But what I want to modify is the footprint. So what I want to do is find its footprint. And there it is. It's highlighted for me. So you can see that it's highlighted. And I'm going to double click on it to open it. And there it is. And notice in this one, the outline has already been added. So the problem we have is that the board has not been updated. So this one has got the outline on it. I'll show you real quick what we would do if that outline wasn't there. And I'm going to just take those outlines off. So that's what it looked like when the board was built. To add it, I'm going to put in the lines for that outline. So I click the line tool, and it's already in a width of 5, which looks pretty good. It's on the layer 21 top placement. That's the layer I want because that's going to, top placement's going to become our silk screen layer when it's built later. But I want to change my grid. And so I'm going to use the grid command, upper left side. Right now it's at 50 mils. I want a little more accuracy, so I'm going to take it to 5 mils. And okay. And it's probably hard to see on the screen, but now my grid has gotten a lot finer, so I've got a lot more control over where I put that line. So I put the line in, and I'm just going to outline this thing. I'm going to stay about one of the little squares, which are 5 mils or 5/1000ths of an inch, outside the red area, which is a restricted area. That's what that red is designating. And so there's the outline. So I made that change, and I'm going to have to save it. So I'm going to do File and Save, and I'm going to close this editor. And this is always scary for me in Eagle, because the close is actually the X close command, and it's just going to close the editor. But notice it did not update anything. That outline is not there yet. So what I need to do now is update it, and I'm going to do Library, and then Update, and I'm going to select the Scaled Automation one. And I'm going to say Update. And so it gives you a warning, says the library update has modified the board. Please run a design rule check. In this case, because of the fact that what we're updating is just the outlines of the resistors, we don't really need to do a design rule check, because that's not something that's going to mess up our traces. But notice now, when I'm in the manufacturing tab and I'm looking at it, look at how those resistors now are nicely outlined. But also notice that my capacitors are not, because we only did the resistors. So let's close that. Let's go back and double check our capacitors to see what they are. So right click on the X right in the middle, hit Properties, and it says that it's a C0805K. That's the footprint. That's what I need to know. So let's go back into Library, open Library again, and again open up the Scaled Automation library, because that's where I kept it. That's where I built it from. And I'm going to look for a footprint now that says C05. And I may not have it in here. It might be from a different library. Okay, so what we're going to do is then I'm going to add that device. And I'm going to do an import, and I'm going to search for it. So I typed in C0805K, and it says no match. I love it. There's always you never know. Well, it did not find it. Okay. So what we're going to do then is I want to show you another thing, actually, because actually the other thing you can do, there's one other methodology we can do, we'll close that out, is that we can replace this device. So I'm going to right click again on it, and I'm going to do a replace. And this brings up all these different libraries. And what I'm looking for is not here. And I think I know why, because I wanted to show you how to add a library. So let's open Library Manager. And this one shows in design, in use, and available. So in design, it shows all the libraries that we have that we're using right now. I want to add one to it. So I want to do available. It takes a little bit of time here because it's fetching the library updates. So hold on just a sec. Okay. Okay, so I'm going to do a browse, and the one I'm going to look for now is one that I saved earlier, and it's actually in the Eagle that I used for the company. I have a special external hard drive that I put it on. So I'm in that external hard drive now, and it's under speedometer Rev A, and it's a Speedo Rev A library. So I'm going to open that one up. I'll click it now, highlight it, and then at the button says Use. So I want to allow that one for my design, so I'm going to use it. And I can close out of it. And now Speedo is here. And now I can open up Speedo. Oops, right click, sorry. Remember what I'm doing here. And I want to add from that one, there's why it had CEU, C-EU in front of it. I'll say OK. So now, if you look here, what happened, notice it put the outline around it. So what I did was replace the symbol for that one. Let's do the same for the one below it. Hit replace. And it remembers where you were, which is really cool because I can just do it very quickly. See how quickly that was? Keep doing the replaces. And now it's pulling that symbol out of that other library, and that other library had the outline in it, which is what we wanted to do. And if I go back, I didn't do them all, but if I go back now to the manufacturing, oh, come on. I think you can see it. So you can see that C1 and C2 both now have the outlines on it. So we did what we needed to do, but the outline interferes with the text. So let's, oops, hit the wrong button. So the outline interfered with the text. I'm going to zoom in, and I'm going to move that text, and it has little crosshairs. That's what I clicked on, and I'm going to do the move command. Oops, now it's interfering with the plus sign. So I'll move it over here. I'll move C1, and we'll move it. So very quickly and easily we can make adjustments. Okay. Okay, so we modified the device, showed how to modify the footprint to show an outline. We hit File Save to save it. So now let's talk about making a device from scratch. And what we want to do to make a device from scratch, we're going to need a symbol and a footprint. We need a data sheet for most parts. And we can use a similar symbol if available, similar footprint if available, create a new symbol, create a new footprint. So I'm going to show you the one I want to use to make a footprint out of. And I just got to find it here. There we go. So this one happens to be a MOSFET, and I'll scroll back up to the top. This is its data sheet. So it's data sheet, and I'll also fit the width so you can see it better. It's an N-channel enhancement mode MOSFET. It's a part number BSS138. And it comes in an SOT23 package, and it has the top view that shows you where the gate, the drain, the source connections are. And we'll go back, because what we really need to make this thing are a symbol as well as to make the traces. And here on this page, it gives you the data. Here's a top view right here. It gives you some dimensions. And then here's the suggested pad layout. So this is what you want to find when you're making one. You're going to want to find these pad layouts. You'll also want to know the dimensions for a top view for putting an outline on the board. But the most important is probably these pads. And if you recall, up at the top, it showed you which pad was which particular one of the signals. Pardon me. So this gives us our values. And by the way, notice I have to do a little bit of math because the center X, or the crosshairs, is going to be 0, 0. I have to figure out where the 0, 0, what the coordinates are for the other crosshairs. It gives you the values. But for example, for the top one, the X value that is going left to right is going to be 0 because it's right on the 0. But its Y value is going to be half of C because C is from top to bottom and it's symmetrical. So half of C, C being 2 millimeters, is going to be 1 millimeter. So I printed the sheet out and I just put the coordinates out here on the sheet so I could have them handy when I go to make it. So we go back to our circuit, and we want to add this device in. We need to open up our library that we want to put it in. And I'm just going to use the speedometer Rev A library. And I'm going to add a device. Now this time, instead of looking it up, I'm going to type it in. BSSS138. Create a new device. Yes, that's what I'm trying to do. And it comes up blank. So there are 3 areas here. There's a description in the bottom. We can type that stuff in later. There's in the upper left corner is where the symbol's going to go. Now there's a good chance that we might already have a MOSFET symbol. So let's see if we can find one. Oh, it's not in our package yet. So we don't have one in there yet. So we can't really create that part here yet. So let's go back and to our library table of contents, and under symbols, as I know there's probably MOSFET out there, I clicked add symbol. Now I'm going to import, and it says to save, so we'll save, and we're going to search for MOSFET. And look, it found a whole bunch of them. There's a symbol for an N channel, an FET-N. That looks like a good one, so we'll use that. We'll add that to our symbol list. And here's what it looks like. So let's go back to our table of contents and go back to our device BSS138, which happens to be at the top. I'll double click on it, and we can add that symbol, that part in. It's FET-N. Put it right over the crosshairs. It's maybe cancel, sorry. I'll zoom in a little bit. Maybe hard to see, but there's a crosshair right here. And notice it's not quite lined up with their crosshair, but that's okay. It'll work. But what we don't have is we don't have a footprint yet. That was what we needed to do. So we're going to go back to the top toolbar, and there's one for footprint. And we're going to put a new footprint name in. And I'm going to use the same name, BSS138. Create a new one, yes. And now we've got our grid. Our grid we want to change to millimeters. It's in mil, so we'll change that to millimeters. And we'll change it, since I know we're going to at least need halves, I'm going to go 1/2 a millimeter for now. And now we've got our grid. With this grid in place, let's put in the first pad. And those pads happen to be 0.8 millimeter wide and 0.9 tall. So over here on the pad, come in, I'll click that. Ooh, and I got the wrong kind of pad. So we're going to have to edit it. Oh, sorry, that's what the problem. I hit a hole instead of SMD. It's right next to it. And notice up here at the top, it's got sizes. So I'll drop down and see if it's there, but of course it's not. It never is. So we're going to have to put in our own sizes. So the first part is going to be the 0.8 millimeters, and then the other part's going to be the 0.9. And I'll put the zeros in just because. Roundness will leave it 0. Notice it changed it. So now we've got our pad in, and I'm going to put it in an approximate place. It doesn't have to be exact yet. And also notice there's up here, as I move around, it shows you the coordinates. So I need it at 0 and 1, and there it is at 0 and 1. So it would happen to be there. That's pad 1. So then we'll put in pad 2, and it needs to be at negative 0.95 and -1. Well, I have a -1 and a -1. I'm going to go ahead and put it for now. I'm going to show you a cool feature. So once it's in there, it's not quite precise, but I can right-click it and properties, and I can edit where it goes. Position needs to be at -0.95. So I could have changed my grid, but I can also do it this way. And it moved it over just slightly. The other one, the same thing. It needs to be at positive 0.95 and -1. So I just edited it in. So there's my footprint. And it's that easy to put in footprints. So then we'll do File, Save. and our footprint has been edited. We go back to our actual device, and we're going to hit new on the bottom, and we're going to add from local package, and we'll add that BSS138. And now we got a symbol and a footprint tied together, and all that's left now is connect them. This connect step is interesting because it ties the different signals to the correct pins, and we'll just connect them up real quick. And be careful of that. Make sure your pins and your symbol legs are correct. And now we've got our symbol created, our entire package created, and we can save it and use it as needed. So that's our steps today for going through how to actually make a device from scratch. We created a symbol. In this case, we used one that was already there, but we could have drawn it. We created a new footprint from scratch using the dimensions based on the data sheet. So we went through all that, created the new device. We connected the symbols to the footprint, and we finished it up by saving it, and now we can use it. And that's how to make symbols in libraries. So if you have any questions, I'd appreciate it if you'd send me emails or phone, texts, or just call me, and we'll be glad to answer questions. And that wraps it up for today.